Okay, so page 9. Let's just try a few. Maybe this will do it for you. So we gotta apply our knowledge of probability and odds. Determine the odds. So you gotta read carefully. Is this probability? Is this odds? Okay. The odds in favor. Guys, let's try to be on time. All right. There's a bell for a reason. If it happens every day, it's a little annoying. Okay. Determine the odds in favor of choosing a face card from a deck of cards. So let's do A right here. You got to be careful. Odds in favor. So they always go together. Will be either odds in favor or odds against. It will go together. If it says odds in favor, you got to think of what's the event we're talking about here. What are we after? A face card, correct? So that means that my face cards will go here, and here we will have anything that is not a face card. Do you remember what I do when it's not it? We go total minus what it is, and then we get the knots, okay? So face cards, we've got 12, and therefore, how many non-face cards? If you have your little study sheet entry for a deck of cards, there are 40 that aren't, but I go 52 minus 12, so 12 to 40. That's not reduced. So you can, they're both even, so technically you slice them in half, right? 6, 20. You slice that in half again, 3 and 10. Once usually then you're done. If you keep slicing in half, you get to a point where you can no longer. And the only reason that I want you to know how to reduce somewhat is because it could be a multiple choice question where the province sets this question up and they give you the options reduced. So, what now, right? So you got to know a little bit of reducing. Did I do the calculator thing on reducing? I think I did. So I'll just leave it for now. B, determine the odds against an ace. And there is again odds. So we know the format. And this time it says against. Okay, so they always will give you both, right? Odds in favor, odds against. If it's against, what are we after here? We're after ace. So then the ace, the actual event is going to be on the right side. And so all the non-ace cards will go first. Okay. So we've got 4 aces, and therefore we go 52 minus 4. That's 48 to 4. I can get 4 into both of them, correct? We can divide this by 4, divide this by 4, so we get 1 and then 12. So usually when you can reduce them, they'll be fairly straightforward. All right, C, the probability of an event happening is 2 over 5. So the odds against that event happening. So probability of event is 2 over 5. What are the odds against? So they're asking for odds, but it says against that event. So that means that event goes here, and the event not happening goes first. So now you just need to be strategic. The 2 represents, right, the probability of, so those are the favorable outcomes of the event happening. So the 2 will go here. And on this side, what is my total? It's 5, right? So we'll go 5 minus 2. So it's 3 to 2. You should always be able to add the numbers up and get back to your denominator. Okay. So out of a total of 5, two times the events will happen. And you should kind of tell that 3 times it will not happen out of the 5. Okay. D, I will just do this first question, and maybe if someone has a question, I'll do one more. But I will post the key today or tomorrow at some point. The odds in favor of choosing a female are 35 to 55. So we're told that the odds in favor, so that means that the event will be first, of choosing a female are 35 to 55. What's the probability of choosing a female? Probability of F would be females over what goes down here? Total, right? All possible. I think that the total is the easiest. You just always, when you're going from odds to probability, you're going to add up these two to get that number. So I will actually show it here, 35 plus 55. And now you have to choose which number goes on top. In favor of female, that means that these are your females, right? These, therefore, are not. Okay. So the 35 goes up here. So it's 35 over 90. This is a mistake right here, okay? If you were to go, I know it's very packed here, but you decide whether going 35 over 55 is incorrect, okay? That is not right. Like, a lot of students are just like, oh, there's two numbers, that's convenient, just put them in the fraction, we're good. Avoid that temptation, okay? They are going to test you on it if it shows up. They will say, hey, here are odds, turn it into a probability. The first thing they'll be looking for is, are you understanding that you need to add both of them because they mean opposite things, right? They literally mean opposite things. Good? If you're scratching your head, any questions about any of these? Yeah. You don't have to. 5 goes into both, right? So you could, we could do 5 goes in there 7 times. 5 goes in here. 18, yeah. 18 times. So, can you see that? Yeah. Okay. So, and I don't know if I showed you the trick, but it's 7 divided by 18. You can hit enter, or you can just go math and then select the first option. Oh, that's already reduced, my bad, sorry. 35 divided by 90, math, enter. It will reduce it for you, 7 to 18. Even if you have odds like this, just treat it as a fraction. Just go 12 divided by 40, and then just go math, enter. It will turn it 3 to 10, so it will reduce odds for you if you're careful enough. The only thing is something like this, for example, 48 over 4. Yeah, I don't think it will do it. Let's see. Yeah, no, it will just divide it, right? So you get 12. So then you would have to enter it in the reverse order, as long as the denominator is smaller, and then go math, enter. So you just need to understand that the 12 should stay here and the 1 goes over there. Maybe I'm making it too complicated with the calculator. Maybe just stick with what you're doing. Maybe I will just one. I don't know if you did this, but on page 9, question 3, can you turn both of those odds into a probability? Just real quick. Let's do it in 2 minutes or less. It's asking which game would you rather play, and obviously you would want the highest winning, the probability that like the game that has the highest probability of winning. Try that. Okay, so the odds against winning Zim are 5-2. Odds against winning. So that means that in this particular case, winning, the 2 goes to win, and the 5 goes to not winning. So no surprises, right? Why would you be winning more than the game wouldn't make money, right? The odds against winning Zap are 7-3. So again, this is winning, this is not winning. Which game would you rather play? I would say find a probability for both of them. So for Zim, we've got 5 plus 2, and we've got 2 up top, right? 2 represents the winning, so this is 2 out of 7. That's the likelihood of winning. When you want to know which one is more likely to win or which one should you be going with, turn it into a probability. That's the way to go. Probability of Zap. First thing you should probably do is just add up the 2, right, that make up the odds. And the 3 represent the time you would be winning. 3 out of 10, essentially. And if you still can't tell, turn it into a decimal. Okay, so 2 divided by 7, that'd be 0.2857. By the way, I tend to round to 4 decimals here, because if you multiply that by 100, it's very easy to turn that into a percentage. And if you watch the lesson, I tell you why. Okay, there's a reason why. Otherwise, if you go 0.29 and multiply that by 100 to say 29%, that is rounded incorrectly. But if you round to 4 decimals and then multiply that by 100, then it's fine. This one is 0.3, which is 30%. Here you can clearly, you could have already been able to tell there that Zap is more likely, you should be playing that one, right? Should play Zap because it has a greater chance of winning. You have a greater chance of winning, I guess. So that's how you do that. Okay, let's move on to, if you want more practice, all the way to 13 is game. So I'll post all the key to all of that if you need to practice that. I'm gonna stop there and start a new video.